All right, we're going to be talking about adding and subtracting rational expressions. Now, rational expressions are like fractions. And so if you remember, when you're adding or subtracting a fraction, you have to have a common denominator. So that's the key to this, is that you have to have a common denominator. So if I were to add a half and a third, I'd have to have that common denominator of a sixth. So we're going to start off by having the same denominator, okay? So our first example, I have 4 over 3y plus 7 over 3y. So if I'm going to add these, I don't have to change my denominator because it's already common. So this becomes 4 plus 7, or 11 over 3y. There's my simplified expression. Now, this is nice because these were pretty straightforward, right? They were the same denominator. We were able to add the numerator. Our next example, we look at our numerator first. We look at our denominator first. If they have the same denominator, so that's good. Now we can subtract because we're looking at subtracting. So the key to this, though, is a lot of mistakes are made because what they do here is they go 7x minus 4x, and they get that correct. But what they forget to do is take this negative sign and put it towards our last term here. So this is actually 5 minus 3 also. So understand that that negative goes to both terms in the second piece there. And so since our denominator is the same, I'm just going to rewrite it here. Okay. So I have 7x plus 5 minus the quantity 4x plus 3. So that gives me 7x. I'm going to do this step by step. Minus 4x minus 3 all over 3x squared minus x minus 2. Now I'm going to combine like terms. Okay. So I have 7x minus 4x. That's 3x. I have 5 minus 3. That's 2. I probably should look at if this factors or not. Okay. This bottom part, I typically want to factor this bottom here. We'll talk about that in a second. So this bottom factors into 3x plus 2 times x minus 1. So I probably should talk about, just kind of mention it, that anytime we're dealing with rational expressions, we got to make sure that we understand there's values that we can't use. So in our first example, I have a y value here I can't use of 0. Okay, so I just wanted to make sure you understood that. Now, we've talked about simplifying rational expressions. So back to example 2. I have 3x plus 2 over 3x plus 2. Those cancel out, leaving me with 1 over x minus 1. Just make sure that you understand that here I can't use the value 1 and I can't use the value negative 2/3. Okay. So we want to get in the habit of looking at these, factoring our denominators. We'll kind of look at that later on, getting that common denominator. So in example 3 here, we have two denominators that are not like each other. I have 6x and I have 2x squared. I have to get them to be a common denominator, okay? So the way I do that in this first part, when I'm just dealing with a monomial, is I look at the coefficient first. So I'm going to look at 2 and 6. Well, what is a common multiple of both 2 and 6? Well, it's 6. And so I know that my denominator is going to have a 6, okay? Maybe I should write that down a little bit farther. So I know it's going to have a 6. And now I'm going to look at my variables. So I have x and x squared. Well, when I'm dealing with variables, I always use the highest power. So whatever the highest power is, that's going to be in my denominator. Okay? So the higher power between 1 and 2 is 2. So my common denominator is going to be 6x squared. Okay? So I'm going to come back up here and I'm going to kind of put in this row here. 5 times 6x. Well, 6x times what is going to give me x squared? Well, 6x times x is going to give me 6x squared. So I have to multiply the top and bottom by x over x. Okay? Plus 3 over 2x squared. Well, 2x squared times what is going to give me 6x squared? Well, 2 times what gives me 6? 3, I already have the x squared, so that's taken care of. So I have to multiply top and bottom by 3 over 3. Okay? So now I can kind of do some simplifying here. X times 5 is 5x. 3 times 3 is 9. And there is my simplified expression. Understanding that there is a value that I can't plug into that denominator. Okay, I'm just simplifying right now, so that's fine. Now in example 4, I have two very unique items here. I have 3 over d minus 1, and I have negative 2 over d plus 2. So I have two different denominators. Now, a lot of times when we're looking at these and we're trying to find a common denominator, a lot of times a common denominator is just the product of those denominators. So what I'm going to do is I'm going to multiply this fraction by d plus 2. I'm going to multiply this fraction by d minus 1. So I have d plus 2 over d plus 2 times 3 over d minus 1. Okay? So my common denominator is going to be the product of these two denominators. Minus 2 over d plus 2. So it's missing the d minus 1. So I'm going to multiply top and bottom by d minus 1. So now I have 3 times the quantity d plus 2 minus 2 times the quantity d minus 1 all over d plus 2 times d minus 1. Okay. So I still have to do some simplifying here. So I'm going to multiply through by 3 and negative 2. So I can simplify this. So this becomes 3d plus 6 minus 2d plus 2, and so all over d plus 2 times d minus 1. Simplify now, d plus 8 over d plus 2 times d minus 1. Can I cancel any of these out? The answer is no. And so now my final value is d plus 8 over d plus 2 times d minus 1. So remember, in adding and subtracting rational expressions, the key is to find that common denominator. It may be just the product of the two denominators. It might be multiplying by two different values. So that's adding and subtracting rational expressions.